Yeah, hi. Good morning and good evening, everyone. Welcome back after a long gap. So we were discussing Terraform from long back, and then we are creating infrastructure, everything through Terraform, and then we have learned the security groups, and then EC2. Many features in EC2 that is like launch template, target group, launch template, auto scaling, and then auto scaling policy, ALB, listeners, and rules. Okay, so these are very important as part of high availability. So whatever the interview you attend, whatever the assignment you take it. So these are the 80% of the concepts you have to implement while giving the solution for that assignment. Okay. For example, last few days back, I posted an assignment. That's the real assignment from a top company in Singapore. Okay. So try to complete that assignment by the end of the course. So mostly our whatever we are discussing, so we covered. So you can definitely clear that assignment. Okay. So today's session, I already created the security groups. Okay. So for reference, you can always check here. I have created sg.aml. Okay. So basically why I created as in AML format is you can tell about yourself. AML is the to say it's a public format. You can mention anything in AML format. For example, if I ask you to tell about yourself, you can also mention in AML format, name, date of birth, your mobile number, your email ID, your skill set. Your skill set is like you have a list of skills, and then the companies you have worked, you have a list of companies. Okay, so in the same format, I have just created one AML file here. You can see these are the security groups we have. In the DB, we have MongoDB security group, Redis security group, MySQL, and RabbitMQ. In apps, we have catalog, user, cart, shipping, and payment. In web, we have web security group, ALB, we have web ALB, and then app ALB, and we have VPN security group. And you can check here the ingress rules we are implementing in every security group. Okay. So for example, here you can say, you can take So here you can take MongoDB should accept connections from catalog. So that's what I mentioned here. MongoDB, first it should accept connection from VPN on port number 22. If something goes wrong, we will log into MongoDB and then we will check. And MongoDB catalog. So MongoDB should accept traffic on port number this and from catalog. Similarly, if you have seen here, app ALB. So generally without Terraform, right, without security groups, how we were connecting is cart is connecting to the catalog. So you are giving catalog endpoint in the cart service. Okay, so that's what here you can say. If you see cart is connecting to the catalog. Okay, but here cart cannot directly connect to the catalog. Every time the connection should go from app ALB and then catalog. Okay, so now it should happen like cart to app ALB, and this app ALB will call the catalog. So here if you see app ALB should accept connections on port number 80 from cart. Okay, catalog should accept connections on 8080 from app ALB. Okay, so like this, every component will connect with another component through app ALB. So that is mandatory. You need to remember that. So you can refer this AML file and let me know if any corrections are there. But I hope no corrections because I already checked it. And then you can check here in main.tf. So I created all the security groups and then ingress rules. Okay, so I created all security groups and I created all ingress rules just in this order. So whenever you have doubt, you should immediately check here. So till user, okay. So, we implemented a module. So that module is creating target group and then launch template, auto scaling policy, and then listener rules. Okay. So I already implemented till user. Let us test this. Join DevOps.online. Okay. So we are able to load the categories, and then user module can just test. So till user module, it is working. Now we need to work on cart module. Okay. So now since you have implemented everything, okay, so you have the module that is RoboShop app. Where is it? RoboShop. Terraform RoboShop app. Okay. Here we have our all resource definition. Here we have our variables. Okay. So now let us implement the remaining cart. So before implementing cart, we already implemented Redis. Now, yeah, this is cart. Main.tf, data.tf, variables.tf, provider.tf. Okay. So I'll just copy this and then change it. So instead of user, I will take cart. Replace cart SGID, and then user data. You should not replace this one. Okay, go next. Replace and then replace. That's it. Okay. So now you should have cart SGID here. I'm taking the data also. Here also I will replace. Cart SGID. That's it. And take the provider. Copy the provider. Replace cart. And then variables. That is cart. Here also it is cart. So I think there is no, yeah, it's not there. And finally, we need to have cart.sh. Just copy this and inside cart.sh. Okay, when you are practicing, just check this cart.sh once. RoboShop shell tf cart.sh. Okay, make sure you have this right folder. Whatever you have the folder, make sure you have this right folder. And then inside cart.service, here, very careful here. Here catalog port is not 8080, it is 80 because we are calling through the app ALB. Okay. App ALB is on port number 80. Listener is on port number 80. So if you call catalog directly from cart, then it was 8080. But now you are calling through the app ALB. App ALB is on port number 80. So you make sure you have port number 80 here, not 8080. Okay. So that's it. Our cart should be ready. CD10 got Terraform init. Terraform plan. Just do I have the old one? Okay, so maybe I had some old one from the previous. Arcade group, and then what else? Launch template auto scaling. Now Terraform plan. Okay, that's good. And Terraform apply auto approve. And so this will take a few minutes because we need to create the instances, and then instances should download that user data and run itself. Okay, let it create, and then let us work on the another modules. So after that, we need to have our MySQL so that shipping can connect to the MySQL. Okay, so I can have MySQL main.tf. So this is not application, this is database. So we don't need that auto scaling everything. Actually, these service, we have services for MySQL in Amazon, that is RDS, and for MongoDB, we have DocumentDB. So Redis, we have Redis service. So we are all going to cover this in upcoming sessions. Okay. So instead of using these instances, we need to use those services. Variables.tf and then provider.tf. So I'll copy this MongoDB because the same Redis or MongoDB, whatever. So we can have T3 medium and then let me copy the data also. Okay, VPN database subnet, and instead of MongoDB, we should get MySQL, and then here it is MySQL SG underscore ID. MySQL.sh, and it should be MySQL, and here also MySQL, and here also MySQL instance. Everything is correct. Let me search for any Mongo. No, any Mongo. Not here, provider. SQL, and then variables. So this is good. And we should have mysql.sh. So let me take this. But we are using -tf, cd this one, and mysql.sh. So let us check any changes we need here. MySQL.sh is already RoboShop, this one. MySQL.repo will be copied, and this will set up the MySQL. Okay, so let me do something. Yeah, here priority 20 is already in use by user. So obviously we need to give priority 30 for COT. What is this priority? Yeah, here 30. So catalog have 10. User have 20 already. And then here, yeah, this is fine. Just apply once again. So let us check our instances of cart. For example, take this one. First, log into VPN. From here, log into our cart. Check the logs, var log cloud output.log. Okay, it was success. Now let us check the load balancer rules. App ALB rules, and here we have our cart. This is the target group, and you should get the instances as healthy. Okay, so this is good. Now let us check once again. Kumar, 1, 2, 3. Okay. Add to cart. Okay, cart is working. So now once again, just repeat with me what will happen. Okay, so this will be good for your debugging purpose whenever you get an error. Suppose you get error here. Okay, so just repeat or at least remember with me. So what happens? The sequence of requests. So https://joindevops.online. So where the request will go. You can send in a chat. Okay, first Route 53 will get web ALP. Okay, so now request will reach web ALP, and so a listener is running on port number 80. Okay, so listener is on port number 80. So our request will reach the listener. So now the listener will check if host is joindevops.online, send this request to the web instance. Okay, so that's what it is mentioned here. You can just check. Our load balancers web ALP. So here there is a listener rule. If any request on joindevops.online, send that request to the web instance. Okay, so this is on port number. Listener is running on port number 443. Sorry. Okay, so now the request went to web instance. Now we will get the homepage of RoboShop. So and immediately, so you can just see when you are getting this one, I'm going for inspect and then network. So this home page immediately will send a request to the categories. Sorry. Okay, so this home page immediately send a request to the categories. You can see this. Okay, get this. So now here again the request will reach to WebALB, this one, and then it will go till here, web instance. Okay, and here in Nginx, web Nginx, roboshop.conf, we have a rule. So what is it? We have a rule here. If this one is like this, or API/catalog. Okay, if it is /API/catalog, then how we configure? We are sending this request to the catalog.app.joindevops.online. Okay, so what is this catalog.app.joindevops.online? What is this? Can someone send in chat? What is this? So this is app ALP, right? App ALP. So why we are implementing app ALP? Components are not allowed to connect directly with each other. Okay, so they should go through the load balancer because we don't know how many instances are in the background. So this app ALP, it will go. And then this app ALP is running on port number 80. Since it's private, you don't need to implement 443. Okay, and then so app ALP listener AT have a rule. If host is catalog.app.joindevops.online, send to catalog target group. And we already configured port number 8080. So this is how the request will go. Similarly, the same way for the API/cart. Okay. Yeah. So if I just hit any add to cart here, you can see the request is going as a /API/cart. Okay. So this is how you can debug. At any point of time, you are getting some errors, log into those instances through VPN and check the logs and then proceed with another instance. So you can clearly see the error. Just you have to be patient. That's it. So now let us install our MySQL. So everything is fine. So now let's go with MySQL. Terraform init. Terraform plan. So one thing is missing. We don't have subnet ID in the local. Just copy that locals.tf. Terraform plan. Okay, so there was some old record left. Delete this. Terraform apply auto. Okay, so let it create. Now we can concentrate on shipping. Okay. Again, the same copy paste in .tf provider.tf variables.tf data.tf. So let me take this users. Instead of user, I want it shipping. Don't replace this one. Just go replace this, replace this. That's it. And then data. Okay. Instead of user, find out and then replace. That's it. And then provider. Instead of user, make it shipping. And then variables. Instead of user, shipping, 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 shipping. Okay. And here there is one thing here we need to change. Here it should be 40. And we have shipping.sh here. Shipping.sh. Okay, make it this one. RoboShop shell TF. Yeah, here it is. Shipping.sh, and then just go and then check this one. Shipping.sh. It should be -tf. And you have to check shipping.service. Here it is cart.app. And MySQL, this is correct. Yeah, and it is not 8080, it should be 80. Okay. Or else you can just remove this. That is fine. Okay. That is set. And let us once just check the MySQL instances are properly running or not. Such CentOS. Var log. So copying MySQL repo is an error. Okay, so what is the error? Just go and then check. No such file or directory. MySQL.repo does not exist. Why is it not exist? MySQL.repo. Why is it not exist? Let us just check. So I didn't set up the directory here in MySQL.sh. Yeah, it is in temp directory. Okay, so should do it CentOS. Okay, so let me destroy and create. And we have shipping also ready, but we need MySQL for that. We need to wait. Let us check once our shipping.sh. It is on cart. MySQL, this is fine. Yeah, this is fine. Let us see if we get any errors. Need to push the changes. Thank you, Chandrasekhar, of shipping. Instance is created. Let's try to connect as a such. CentOS at the rate. This will take some time to initialize. Okay, we are into MySQL. Can just check add log cloud init output. Installing MySQL in the background. Okay, let's hope that will be success, and then we can check and we can go ahead with shipping. Terraform init. Terraform plan. Okay, so MySQL is success. Now we will apply. Okay, MySQL is success. So this will create the shipping. So meantime, we can work on RabbitMQ. Same process, main.tf variables.tf data.tf and then provider.tf. Okay, let's take this main.tf. Instead of MySQL, it should be RabbitMQ. Okay, this is good. And then this data also. Instead of MySQL, there should be RabbitMQ. And then provider. Should be RabbitMQ. And then variables. And RabbitMQ. And let us have RabbitMQ.sh. Should be RabbitMQ.sh. And let us check once again that RabbitMQ.sh. This RabbitMQ.sh. Yeah. So I think there is no changes. There is no copy. There is no copy such thing. And then here in RabbitMQ.sh, RabbitMQ.sh. And then we need to have our locals. Okay, that's it. Now shipping is done. Let us need RabbitMQ and then check. So shipping is done properly. We need to get this. Go to cart, checkout. Okay, the shipping server. Let us go and then check shipping servers. Maybe they are still running. As I search CentOS. Shipping is running in the background still. Okay. So now it is done. Let us start from the beginning. Go to cart, clear this checkout. So we got something 500 error. Okay, so now this is the best to troubleshoot. Okay, so let us see where the error is. Internal server error. First, let us see directly inside shipping. Maybe we get something directly here. Var log messages. So there is no error here. Let us check once again. Cart, checkout. Now you can see the okay. So it was just taking some time to fetch the data. That's it. Sydney. Okay, shipping is done. Now RabbitMQ. So provider. So you have to be careful while dealing with this. If you give the provider of MySQL here, then everything will mess up. Terraform plan. Terraform apply. Okay, so let the RabbitMQ run and we do on our payment part. Okay, main.tf, data.tf, variables.tf, provider.tf, and then payment.sh. Take the shipping and then replace. Payment, payment, payment. And make sure you should change your rule number. Copy the data. Replace shipping with payment. Save provider. Copy shipping with provider and variables. Shipping to payment, 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 payment. So that's it. Okay, and payment.sh. Okay, and we need to be careful here. RoboShop Infra Shell TF payment.service. Okay, change the ports. Cart user RabbitMQ is same, but it should be cart.app user.app. Okay, that's it. And make sure push this. Okay, place it in provider. Thank you. Okay, we pushed already. Now here 14 payment Terraform init. Let us check our RabbitMQ is working properly or not. Copy this. Exit. SSH CentOS @DevOps 321. Tail -f var log cloud init. Okay, RabbitMQ is going on in the background. Let us go for plan of payment. What is it? It's saying net stat -lntp. Yeah, 5672 is running. That's good. Now apply. Okay, so let the payment will go on. So that's it. Our mostly we completed Terraform. We completed the important practical aspects of infrastructure. Okay, we have few simple concepts left, that is like provisioners and then importing the existing resources into the Terraform already. So those are not practically important, but very important for the interviews. Okay, two things: provisioners, and then what else it is? Importing the existing resources. So these two topics we will cover anyhow. So because we are doing this from long time, maybe you get bored. So now we have to enter into the Jenkins part. Okay, we will discuss these two, don't worry. So that is continuous integration. Okay, so what is continuous integration? Before understanding this, let us understand what are we doing from long back. So when you write shell scripting, okay, what we did, we developed in laptop, we push to Git, and then we pull to workstation, and then we run shell script there. workstation or run in pull to instance like cart, catalog, whatever. So the same way, laptop, Ansible. So the same way, push to Git, pull in Ansible server, run Ansible playbook. Okay, Terraform. What are we doing here? Okay, we are not pushing to Git anyhow, but it's okay. You can push. For the same way, you can have one workstation, you can install there. So here, for example, I'm developing the Terraform modules and I'm pushing to the Git. So if you want to work directly in your laptop, what you do? So in your laptop, first install Git, right, to pull, and then install Terraform. So these are the steps you follow. Pull Terraform repo, run Terraform commands. Okay, so these are the steps. So your laptop is the computer or server, whatever. You have to install Git, you have to install Terraform, and then you need to run those commands. Okay, for example, if you have more instances like so right now we have two tools. If you have 10 tools like SonarQube, and then we will discuss about those. You have, so remember, just to understand this, you have tools. Okay, so what you have to do, any mission, install the tool, pull the code, and then run it. So here it's a sequence of steps. So you are working with multiple tools. So going forward, you may work with 10 tools, but every time you cannot work with your laptop. So we should not trust our laptops. Okay, our laptops are not reliable, and we cannot trust our employees also. If you keep everything in a employee laptop, security reasons, and then there may be crash. Okay, and it is not so laptop with is not in our data center to manage. There are many rules, many recommendations or many rules. You should not use your laptop as a point of contact or as a single source of truth generally. Okay, if you trust your laptop, anytime it may crash or anytime your employee can leak it. So that is why we should have something called as continuous integration. Don't worry, we will discuss more on this, but for now, let's understand like this. Okay, so this is your laptop. Okay, and then you are developing and then pushing it to the Git. Okay, so we can have one server. So this is like CI server. So what this CI server will do here is it will do a sequence of steps here. Okay, so what it does. So this CI server, obviously, you should install everything. Install Git, install Terraform, and install any other tools, any command or tool. Okay, your CI server, just like any other Linux server. So what this one will do, it will download the code from here. Okay, and then it will run. Okay, Git clone, run command. Okay. So for example, if you take Terraform, so if you want your CI server to run Terraform, you should have Git and you should have Terraform. So while running this, okay, so this is in CI server. Okay, so this is the whole CI server. So this CI server will integrate with AWS. How should it integrate with AWS? AWS account. So this is your AWS account somewhere. So your CI server will integrate with AWS. That is, you should have again AWS command line tool installed. Okay. So CI server is orchestration. Okay, orchestration server. An orchestration server. It can connect with any external tools, okay, or systems if you have that plugin or command installed. So here generally we call everything as a plugin. What is plugin? So you know plug and play, right? So if you have a light, if you just plug it, it will on. Then you can take out and then you can portable light basically. So plugin is a functionality enable or disable. Okay, if you install plugin, for example, if you install plugin, you will get features. If you uninstall plugin, your features will be removed. Okay, so just like install git. So you are installing a command, then you can connect with a GitHub server. If you remove git, you cannot connect. Similarly here, exactly the same 100%, but we call it as plugin. If you install git plugin, then you can connect with Git server. If you install Terraform plugin, you can connect with Terraform server. Either you install plugin or command line, whatever it is. Okay, so continuous integration is actually nothing but a Linux server which have a Jenkins software installed. Okay, remember this continuous integration server is nothing but a Linux server which has Jenkins installed. Just like your MySQL server. MySQL server, what is it? Inside Linux server, you are installing MySQL, then you are calling it as MySQL server. Similarly, Jenkins server, you have a Linux server. Inside Linux server, you install Jenkins, then you will call it as Jenkins server. So that's it. Okay. But the real power comes through the plugins. Okay. How can you connect with external systems? How can you connect with Git? You should have your Git plugin installed. How can you connect with AWS account? You should have AWS command line installed. How can you connect with other systems like SonarQube, Nexus, and many other Ansible, for example, Ansible? How can a Jenkins connect with Ansible? You should have Ansible installed. Okay, so the real power comes through the plugin. So we have our applications like cart, catalog, and then user, payment, shipping, all these applications. Okay, our developers are developing, but till now we haven't discussed about the build procedure. So what is the build procedure generally? Developers are developing. We need to build, create a package like your RoboShop builds we have right in our S3. So create a package and push to either S3 or Nexus. Before pushing, so whenever you are going for building, you have to scan the code, because we cannot trust the persons, we have to trust the process. Okay, so in software or IT or any company, we always listen this: don't trust the persons, trust the process. Persons may stay or may not stay, may leave the company, or whatever happens to the person, your process should not stop, your company should function. Okay, for example, if you take TCS CEO, earlier we had many CEOs like TCS chairman Ratan Tata, then later it is changed to some other person, and then Chandrasekharan, and then now the person is different, but the company is functioning as it is. So companies or projects never depend on the persons, it is always depend on the process. Okay, here we got the person developed the code, you cannot trust the person, so that is why we are scanning it. Okay, so we need to use some tools, we need to scan the code whether the developer had really implemented the best standards. Okay, is there any loophole in the code, is there any vulnerabilities vulnerability, so that hackers can get the loopholes of the code. So that is why we need to follow this procedure. First build the code. In building we'll have two things like compile. Okay. So first thing, you need to compile the code, and you need to scan the code and create the package and then push to the Nexus. So this is called as continuous integration process. Why is this called as continuous integration process? Because this is not the one person, multiple persons, for example 10 developers, everybody is writing their own code. One person is writing login functionality, for example, if you take, and one person is writing sign up functionality, one person is writing forgot password, and another person is writing OTP. So we have multiple persons for the user module, multiple developers. How can you integrate all the code? So this is nothing but integration. So different persons are writing different lines of code. Our job is ultimately to build it as a whole module and scan it, create a package, and then push it to the Nexus. This is called continuous integration. So once you push it to the Nexus or S3, once we push user package to Nexus or S3, so this is called as continuous integration completed. Integration is nothing but adding everything. So you are adding all the persons code into a single package, that is nothing but continuous integration. But in our daily life, everyday developer is writing something, every developer is writing something, but end of the day, you should add it, you should integrate the whole code into a package, that is continuous integration process. Okay, whatever we did till now is a deployment process. Once you have the package available, you can deploy the application. If you don't have package available, you cannot deploy the application. So CI is the first thing. CI is the first thing. Continuous integration. And CD is the next thing. Continuous deployment. Okay. So where this should run? So we already discussed, you cannot depend on the laptops. Okay, so that is why we have a CI server. Inside the CI server, we will have our build tools like npm or maven. We have, right, npm install all those things, maven package, all those things. We will install the build tool, so that if you install maven plugin here, then your CI server has the capability to build. If you install SonarQube plugin here, then your CI server have the SonarQube capability to scan the code, to create the package. If you have AWS command line installed, then your CI server can connect with the AWS server and it can push the package. Okay. Or Nexus, whatever it is. So this is the whole process. You cannot log in. So this is the bad process, right? For example, what is the bad process? Log into Jenkins server. Okay. Run the git command. Run the git command inside server. And then run maven command inside server. And run SonarQube command. So this is not at all automation. Run AWS S3 push. Okay. So this is not at all the automation. The automation is, okay, when developer push code to GitHub. Okay. Now let us think. What is the best process? Let me keep this aside. Let me keep this aside. So now the best process is this one. Git clone is one stage. This is stage. And then another stage. Build. And then another stage. Scan. And then another stage. Package. And then another stage. Push. So this is the CI process. Continuous integration process. So this should not be called manually. Okay. So there are something called events. What are the events? For example, events. You withdraw money. What are the, this is one event. Event of withdrawal. What will happen generally? So when an event fires into software, can take few actions. So what are those actions? So a money is debited from your account. So this is an event you withdrawing. So send SMS, send email. For example, a person withdraw immediate 10 lakhs money suddenly, but he don't have any transactions of 10 lakhs, 2 lakhs like that. Maximum he was withdrawing till now around 10,000, 20,000, but there was an event in his account. There is a debit or credit of 10 lakh rupees. Then send a notification to anti-money laundering team. So these are the events happens. Okay, these are the actions, for example. These are the actions. So when an event happens in a software, you can take few actions. So similarly, here the event is developer pushing the code. Pushing the code to GitHub. Now you can take few actions. Okay. That action is trigger Jenkins CI job. So this is the action. So now what will happen without any manual intervention? Okay. So when a developer pushed, for example, user code to the GitHub, immediately a pipeline will run. So that will clone, that will build, that will scan, that will path that will push. Okay, so this is called continuous integration. That's it. Okay, so everybody is thinking like outside. So CI/CD is a big process. We don't know how to write the pipelines. We don't know how to write. So again, here writing this everything. So you have to write a script. Obviously, the script is like clone, build, and then scan, and then again package, and then push. Just like how we wrote our shell script or Terraform or Ansible, again, you need to write a script. Okay. So to automate something, we need to write the script. So here the script is based on generally Groovy, but again, the same concepts, variables, data types, conditions, loops, functions. Okay. So now we will concentrate on this process of continuous integration. Once the package is pushed to the S3 or Nexus, whatever, now we will use Ansible to deploy. Okay, so this is what we are going to do. So infrastructure, everything is provided through Terraform. You will have your RoboShop infrastructure, and then you will have your VPC, you have your private subnet, public subnet, database subnets, load balancers, everything is there. But once the application is running now, so now our application is running. Okay, when our application is running, so is it done? Okay. So what is the error? Okay, now let us troubleshoot this, and then we can end the session. Tomorrow we will install Jenkins, and then we will start discussing this CI/CD process. Okay, let us troubleshoot this. Payment. If something is wrong, it is frequently disconnecting. Tail -f var log cloud init. Copying payment service is failed. So that is why it's frequently getting payment.sh. So simple same mistake we are doing again and again. Okay, it's fine. What I can do is I can just delete this payment instances. Our auto scaling will automatically create the payment instance, and this time, so this payment.sh already corrected and pushed. Okay, so yeah, that's it. So from tomorrow, we will install Jenkins, and then Yeah, we will start writing our pipeline. So no need to worry about the bookish definitions of continuous integration. Okay, bookish definitions of CI/CD. Okay, so those definitions, those understanding, we can always get it. But just understand, CI server is nothing but a simple Linux server with Jenkins installed, and then having this pipeline. Okay, so this is a popular interview question. What is continuous integration? Continuous integration is the process of building, scanning, packaging, and then pushing the artifact continuously on daily basis. Okay, and then you can explain whenever a developer push the code to the GitHub, it should automatically run this whole process. Okay, that is why it is called as continuous integration. Not only one developer, any developer push the code to the user repository, then obviously you need to run this pipeline. Okay, so that will continuously create the packages. So generally in olden days, what we were doing is once they feel this user module is completed, then we will take this process. At that time, you may get errors in build, you may get errors in scan, you may get errors in packages, you may get errors in push. Okay, so just imagine this, understand this. Assume there is no continuous integration server. Okay, there is no CA concept. So on the deployment day, what was happening here is, okay, we will run everything manually. We will run manually, build, scan, package, and push. If you run it on the deployment day, if it is failure, that just imagine how much time it will take again to correct each and every step and then proceed for deployment. So this was nightmare. Okay, so handling everything on the last day is always a bad process. Okay, precautions. How we are taking precautions every time the developer, for example, sprint is 14 days. Day one, you have 100 lines of code. Do this whole process, CI. Day two will become 200. Again, do the whole process, CI. So day 10 may become 2000. Again, run the CI. So every day you are checking for the errors. You are checking for the build errors. You are checking for the scan errors. You are checking for the package errors. You are checking for the push errors. So every day your errors are filtered, and at the end, last day you may not get errors. So that is how the process is changed through the continuous integration. Instead of doing everything on the last day, why don't we do it on parallelly on the same day? The developer is doing his work. We are not disturbing him, and we are doing our work. So he is not disturbing us. If there is something wrong, then immediately a mail will go to the developer or DevOps engineer. Developers also have the access of CI server. They can check what is wrong here. Why we are getting build errors? Any package is missing. Why are we getting scan errors? Maybe I unnecessarily creating some variables, unnecessarily printing some passwords in the terminal. Okay, so that is how he get the errors, and then so both developers and DevOps engineer can work in sync and cooperation to reduce the manual work, to reduce the errors. Okay, so there are always two types of errors. One is coding, and another one is build or configuration errors. Okay, so developer did the coding very well, but maybe your security group is not allowing for his shipping service to connect with MySQL. Whose error is this? Obviously, it's a DevOps error. Okay, you go to the logs, and then you will check out the request is coming. Shipping is trying to connect to MySQL server, but there is a connection timeout. So obviously, this is not a development mistake. Developer has no work to do the configurations. Then DevOps, you should understand the shipping is not able to call the MySQL. Then I need to check the network connectivity. So there is no security group allowing shipping to connect on port number 33062 to MySQL. So this is how you should analyze. Okay. So finally, what is continuous integration? Continuous integration is a process of building, scanning, and then packaging and pushing the packages to some Artifactory like Nexus or S3 continuously based on some triggers. Okay, we can call this as generally webhook. Whenever a developer push code to the GitHub, okay, we can automatically trigger this whole CI pipeline so that we can daily filter out the build related errors. So that's what you can say in the interview. You can have a few questions and then we can start tomorrow. Just let us see once again. Okay, so this is done. Yeah, any questions? No questions from anyone? Yes, Santosh Avala.
Yeah, hi Shiva, good morning.
Yeah, good morning.
Yeah, Shiva, as this alert right now is good, but I have the one doubt. Right now, my current project are using the microservices, right? So group of microservices, how to communicate it to each other? That is my question.
So generally, you can have reverse proxy, and there is something called service mesh that is too much complicated. Okay, it's not really required. You can always communicate with this thing. So how our web is communicating with each other? Communication is nothing but your catalog should, how your card should be able to call catalog. So generally we call this as a gateway. Okay, this is load balancer. This is gateway for everything. So these are microservices. We are working already on microservices. How these are able to communicate? Through one load balancer or through one reverse proxy.
API gateway is like that load balancer here?
Sorry?
API gateway.
Yeah, you can assume this as API gateway. Okay, so this is where all our requests are going through, right? So you will get clarity once we do with the Kubernetes. Okay. So yeah, we are going to ultimately deploy this into the Kubernetes.
Okay.
Any other questions? Okay, complete your practice. Yes, Kishore.
Yeah, hi Shiva, good morning.
Yeah, hi.
Yeah, actually recently I have attended one interview regarding Terraform. In that actually they were asking about load affinity. That also we are going to cover.
That's not Terraform. That is Kubernetes concept.
Kubernetes. Okay. Web hosting also. Web hosting and
see, I'm not teaching this course based on the interview perspective. Okay, interview perspective is the secondary thing. First, understanding is the primary thing. So node affinity is not a Terraform concept, it's a Kubernetes concept.
Okay. Thank you.
Yeah. Varun Yadav.
Hello. Yeah, sure.
Yes.
Shiva, so here we are using Groovy, right? Instead of Groovy, with the shell script also we can do, right? Pipelines.
Yeah,
creation.
you can do shell script also, but Groovy is the better way. So if you want to write shell script, you don't need to have CI server. Okay, shell script always have some limitations.
Okay. Yeah. So and Go also it will helpful with Go also can we write or
yeah, you can write any high level language. Okay, generally Groovy is a high level language. Go is also high level language. If you write in
Okay, okay.
GitLab, if you write it in GitLab, then you can use directly YAML format.
Mhm.
Okay. So whatever
so
the
there
CA
are so many
server you
CA.
select, whatever the CA server you select, whatever the language you select to write the pipeline, but the process is same.
Mhm. Correct.
Okay.
Yeah, there
So
are so many CI/CD tools, right? So compared to
yeah, everybody is
others
coming
and
up with
Jenkins
their
and
one
others.
CA software like GitHub Actions, Bitbucket, GitLab CI/CD. So and Jenkins, Bamboo, Hudson, AWS Code Pipeline, and Azure DevOps, Azure Pipeline. So there are many things, but whatever the number
Mhm.
of tools, the concept is the same. Continuous integration concept is same. You write your YAML, you write Groovy, you write another thing. So the concept is same. So we are trying to understand the concept. We took Jenkins CA server, Jenkins as an example, because that is a popular CA server in the market.
Mhm. So we are pushing code to S3 or ECR, Shiva, in AWS.
Not
Generally,
code. We are pushing code to GitHub,
artifacts.
package to S3,
Art-
or you
Okay.
can send to the Nexus.
Okay. Sure. Thank you.
Okay. Yeah. So yeah, that's all for today's session. Okay. You can have evening QA session. You can join if you still have any errors here. And then so that's all. Have a nice day. See you in tomorrow session. Bye bye. And evening QA session is there. If you have any errors, please join. Thank you so much. See you.